And here what we do with the Scantron. This is our Scantron machine. It's pretty old. It's dated, I believe, 2012, maybe even earlier. Anyway, for many years we were using these Scantron sheets. There is some form number attached, but the bad thing about our previous experience was that the ID number that you can see here has been tracked manually by the person who collected registration emails and had to maintain some kind of Word document with all students listed. And then we were printing those labels individually for every student in every school team, and then manually were reflecting these registration numbers in that specific area of the Scantron sheet. And then during the test time, students had to fill in this area of the Scantron sheet with their answers. And then of course we put this into the Scantron machine, scanned it, and it worked. So later on we processed the data in some old-fashioned C program to actually calculate the report. What we do now, we decided to replace this entire registration mechanism with the application that I'm actually presenting. And part of this application is actually to print on these Scantron sheets instead of manually printing the labels and attaching them to the Scantron sheet. So how does it look like now? Here are two examples. So part of the software that I've developed is responsible to prepare multi-page PDF documents. And every single page of those multi-page PDF documents is a representation of the Scantron sheet to be printed. So now instead of having a label attached, we print directly on the Scantron sheets. So we carefully position those marks in the PDF document with respect to some internal identity numbers, and we print the name of a student directly on the Scantron sheet. So now, for example, here we have two examples from the same school. The school here is encoded with the first two digits. In this case it is 00 here and it is 00 here. And then these two particular students, the first one has the index of 00, which is the very first one in the team. And this one has the index of 07, meaning that this is the last student in that team, or the 8th student in that team, better to say. And what we do next is actually to scan these Scantron sheets. But here is another interesting advantage of this software. Previously, the Scantron machine was controlled by a PC, old PC running Windows 98 with legacy Scantron software installed. That software is no longer good for the purposes of our application because it's old and it runs only on Windows 98. It doesn't run on Windows 7 or any other modern operating systems. So we decided to use Raspberry Pi for the purpose of controlling Scantron machine. So what we've done, we sniffed the protocol, proprietary protocol that is used between the Windows 98 computer and the Scantron, and we mimic this protocol as the software in Raspberry Pi. So now, this is, by the way, the Raspberry Pi with a touch screen, installed, and the Scantron machine through the USB to serial connector is connected to this Raspberry Pi machine, and the other USB adapter here is used for the purpose of Scantron simulator. So that's another piece of software that runs on that Raspberry Pi, and it actually emulates the protocol that we have just sniffed and implemented in the Scantron controller. So in other words, we can test the Scantron controller without having Scantron machine in place. That's actually very good for the development purposes. Anyway, if now we start this Scantron machine, the controller software, here is the interface. First of all, it detects that the simulator is identified, and by the way, this is also a full stack application, web application. It runs in the browser, so it has the Node.js running in the background and the Vue framework sitting on top. So pretty much in this interface we can control the simulator with these widgets, and let me just show what will it look like for me to start the simulator. So now the simulator service is started, and now I can select the simulator from the list of available Scantron devices, and now I can start the process. So the simulator is configured to run exactly 10, as you can see in this window, Scantron sheets, and that's how it's counted to 10. It randomly chooses the content of those Scantron sheets, but it does it with respect to the specification that we send to actually work with the real Scantron sheets. So for example, the actual form has two regions, the ID and the questions. So the ID field has the vertical orientation, and there are 4 columns, and any number in that column is ranged from 0 to 9. That's what we have our simulator reported. The first 4 digits is actually for the ID purposes. And then we have 40 more digits randomly generated in the range from 1 to 5, denoting from A to E. The only reason for us not to use characters from A to E here is for the easiness of processing, because our question database is also encoded in numbers rather than in letters. So anyway, this second group of digits is random representation of answers, denoting students' answers in the main section. And then the last group here, the 5 digits, in the original software there were a special padding of 5 zeros just to denote that the Scantron machine actually scans well. So students are not supposed to mark anything starting from line 41 all the way to 45, and these are the ones. Since the Scantron machine, since the Scantron simulator doesn't have this appearance of emulating zeros in this place, it just uses allowed numbers in the range from 1 to 5 and randomly picks them. So anyway, this is the scan data for the 10 scans. I can close this dialog, and now I can choose the real Scantron machine from the list. Okay, for that purpose I don't need to, of course, to specify a number of actual sheets, because it will be identified based on the number of actually scanned sheets. So now I reset the counter, no longer have anything in the list here, and let me scan let me scan the previously used one sheet, because these ones are freshly printed, they have no answers attached, but the system of identity is pretty much the same, the first 4 columns in that area here and here. So I will be scanning the Scantron sheet that we already used in the previous years, and let me load it into the machine. Okay, there will be just one, and now I can just hit the start button on the interface, and the Scantron machine does its magic. So we can see number 1 in this position. So if we hit on this number 1, we can see that this is the actual scan data. Just to make sure that the data are correct, we can check the ID number. This is 7038. That's exactly what it was on the label. Now, what will happen if a paper jam or incorrectly oriented form is placed? So every form has the correct direction of how it has to be fed into the Scantron machine. So I will intentionally flip it over and will scan. Error message will show up on the interface saying that the paper jam was in correct form, and obviously this form wouldn't show up in this position. All I need to do is to use the interface of the Scantron machine, hit continue button, take the form and load it in the correct way. That's the same form, but I'm just going to rescan this. Now I can hit the scan button again. Did I press this? Okay, it probably took a while, I'm not sure why. So now they have two forms and they are identical in this interface. But the beauty of this Scantron solution is not just that it randomly scans and actually displays them here, because we have to somehow integrate this information into our registration portal. So it uses Socket.io protocol to actually send the data directly to our registration portal. So here is the result of our previous scans, and let me show. We started from the first 10 randomly simulated attempts, and then here are the two real Scantron data that we scanned previously. Just to demonstrate how it works, let me clean up this window, okay, and then I will use the simulator again, and I will emulate 10 Scantron sheets. So now I'm going to reset my collection of scans. Okay, probably I have to rescan the simulator for that purpose. Okay, now I can reset. Okay, I think I know what's happening. The previous scan to the form with the Scantron machine has to be explicitly terminated on the control panel, so I have to hit enter for the Scantron controller to be released. So now I can actually reset the counter, use the simulator and start. But before I will do this, I want to ensure you that there is nothing in this form. So we hit the button. No, I'm sorry, not this one. Hit the button start. It starts counting and the data appearing in this window. And let us just compare the first one. This is 01124333. 01124333. So the synchronization between the Raspberry Pi unit and the main control interface, as I mentioned before, is accomplished by means of Socket.io interface. We have the Socket.io server running on the main application, and the Raspberry Pi simply contacts this Socket.io server. It runs Socket.io client, and here we specify the URL that it has to use to actually send the data to into. This is hmt.jswcm.net Scantron. This is the live instance of the application. And of course nothing will change if instead of using this Scantron emulator or simulator, I will use the real data. And I want to demonstrate this as the last thing. So I clear up the window, I will use the form, we'll load it into the Scantron machine, and we'll choose the Scantron machine here, and we'll hit the start button. Okay, and here it is. 7038, we already know that this is the correct form. Alright?